let us see the relative velocity when bodies are moving in different directions making an angle theta. Here two cars are moving in different directions making an angle theta between their direction. Then relative velocity of car A with respect to the car B is VAB vector, that is VA minus VB. Its magnitude of the relative velocity is given by square root of VA square plus VB square minus 2VA VB cos theta, and its direction is given by this formula. Tan beta is VB sin theta divided by VA minus VB cos theta, where beta is the angle between the direction of the relative velocity VAB vector and VB vector. So from this equation we can get beta. Tan beta is VB sin theta divided by VA minus VB cos theta. Suppose both the cars are moving in the same direction, then theta is 0. In this expression, if you put 0, cos 0 is 1. Then VA square plus VB square minus 2VA into VB. So it can be written as VA minus VB all square. Then when you take the square root, it will be VA minus VB. Similarly, relative velocity of B with respect to A is VB minus VA. When cars are moving in the opposite direction, theta is 180. Cos 180 is minus 1. So here it will become plus. So now relative velocity of A with respect to B will be VA plus VB, and it will be in the direction of VA vector. Then relative velocity of B with respect to A will be VB plus VA plus VB, and it will be in the direction of VB vector. Now when theta is 90 degree, cos 90 is 0. So the relative velocity of A with respect to B will be square root of VA square plus VB square, because cos 90 is 0. Now angle can be got from this. Angle of VAB vector with VB, it is given by VB sin theta, because here sin 90 is 1, cos 90 is 0, so you will get a VB by VA. Now let us see an example. A man is walking in that direction and rain is falling in this direction. So it is 90 degree. Angle between this is 90 degree. Then relative velocity, here rain is falling in the vertical direction, man is walking that side. Then now let us find the relative velocity of rain with respect to man. That is VR vector minus VM vector. Since the angle between them is 90 degree, magnitude of the relative velocity is square root of VR square plus VM square. Now this is the direction of the rain. Then VM, velocity of the man that side. So now it is minus VM is this side. So this is the relative velocity of the rain with respect to man. So rain, this is the direction. So its angle, this angle is given by this relation. Theta is equal to tan inverse Vm by Vr. In this expression, instead of Vb, now it is taken Vm instead of beta theta. So theta is tan inverse Vb by Va. Now it is Vm by Vr. Now let us see an example. Two trains are moving in opposite direction. This train is moving at a speed of 36 km per hour. this train is moving 18 kilometer per hour in the opposite direction. This train is moving that side and this train is moving to this side. They are moving in the opposite direction. A boy is sitting in this train and watching this train whose length is 90 meter. Question is, how long the boy can see this slow moving train? This is a fast moving 36 km per hour. This is 18 km per hour. You have to find out how long this boy can see this train. Now, relative velocity, we have to get the relative velocity. Relative velocity of A with respect to B is, they are moving in the opposite direction, so it is VA plus VB. VA plus VB. So 36 plus 18. Since they are in the opposite direction, it is enough if you find the magnitude. 36 plus 18, 54 kilometer per hour. VA vector plus VB vector. So its relative velocity is 54 kilometer per hour. Then it is to be converted into meter per second. So it is to be multiplied by 5 by 18. When you multiply by 5 by 18, it is 15. So 15 meter per second. Then length of this train is 90 meter. So when the train is passing, to cover this distance, what is the time required? So you can use this formula. Velocity is distance divided by time. So now you know the velocity, distance, this is 90 meter. So from this we can get the time. So time is equal to d by v. So length of the train, here length of the train is 90 meter divided by velocity, that is 15. So the boy can see the train for 6 seconds. Let us see one more example. A swimmer's speed in the direction of the flow of the river is 12 km per hour. Against the flow of the river, 6 km per hour. You have to find the velocity of the swimmer in still water and the velocity of the flow of the river. Now let Vs be the velocity of the swimmer in still water. Velocity of the flow of the river is Vr. This is the velocity of the swimmer in the direction of the flow of the water. Now Vs plus Vr is 12 km per hour. When swimmer is swimming in the direction of the flow of the river, 12 km per hour. Next, Vs minus Vr. When swimmer is moving in the opposite direction, Vs minus Vr is equal to 6. Now V plus Vr minus Vr will get cancelled. Then Vs plus Vs, 2 Vs. So 2 Vs is 18 or Vs is 9 km per hour. So velocity of the swimmer in still water is 9 km per hour. Now we can substitute here. So 9. So Vr is equal to 12 minus 9. So 3 km per hour.